This is AP Physics2 FRQ 2022 AP Physics2 FRQ. Students perform an experiment with a battery and 4 resistors A, B, C, and D. The resistance of resistors A and C is RA is equal to RC is equal to R. The resistance of resistors B and D is RB is equal to RD is equal to 2R. The students create the two circuits shown above and measure the potential differences delta VA, delta VB, delta VC, and delta VD across resistors A, B, C, and D respectively. First bit. From greatest to least, rank the magnitudes of the potential differences across the resistors. Use 1 for the greatest magnitude, 2 for the next greatest magnitude, and so on. If any potential differences have the same magnitude, use the same number for their ranking. Justify your answer. In another experiment, the students have a capacitor with unknown capacitance Cu. They want to determine Cu by using a battery of potential difference 4.5 volts and several other capacitors of known capacitance. They create circuits with the battery, the unknown capacitor, and one of the capacitors of known capacitance. The students wait until the capacitors are fully charged and then record the potential difference delta V known across the known capacitor and the potential difference delta Vu across the unknown capacitor. Their data are shown in the table on the following page. This is the data. Okay. Next bit. Calculate the amount of charge on the capacitor of known capacitance of 200 microfarads in the student's experiment. Briefly explain why the data in the table provide evidence that the capacitors are connected in series. Briefly explain why connecting the capacitors in parallel would not provide enough information to determine the capacitance of the unknown capacitor if the only measuring device available is a voltmeter. That's it. Now let us start doing the problem. Okay. Here are the two circuits. In one circuit, the resistors are connected in parallel with each other to the supply. In another circuit, the resistors are connected in series with the supply. Okay. Now, he is asking us to note down the voltages across these resistors from greatest to least. Okay. And then the resistances of these resistors are here I wrote down. He gave here, whatever he gave that I wrote it, noted down here. For A it is R, for B 2R, and C again R, D 2R. That means the same resistors. In one circuit they connected in parallel, in another circuit they are in series. That's what the meaning of this question. Now we have to find out the resistance, the voltage across the these resistors. Okay. So obviously A and B have the same voltage because they are parallel to the supply. Am I right? Whatever the supply voltage, both A and B have the same supply voltage because they are parallel. Okay. So they have the greatest voltage difference or the potential difference in the potential difference. Okay. So therefore delta VA is greatest. Similarly, delta VB also because they both have the same voltage. Now coming to the series circuit. In the series circuit, the current will be the same and then the potential difference or the voltage drop will be different across each resistor. Now we know V is equal to IR. Okay. And then the total potential voltage V is equal to V1 plus V2. Okay. So V1 is the voltage drop across the first resistor and then V2 is the voltage drop across the second resistor. Now we know V is equal to IR and I is same for both the resistors. So the voltage depends on the resistor. Am I right? Resistance. Suppose if resistance is more, voltage will also be more. No. Therefore, the D has the higher voltage compared to the C. Therefore, I put 2 here for the D and then 3 for the C. That means C has the least voltage and then A and B have the greatest voltage. That is the answer for this question. Now, this is another experiment. In this experiment, they gave the data. 2 unknown capacitors are connected. How they are connected, the examiner did not mention. They gave the data. Okay. The data is given to us. Now we have to, he is asking us to find out the charge on the 200 microfarad capacitor. Okay. So we know charge is equal to charge Q is equal to CV. And then capacity is known, capacity of the capacitance of a capacitor is known to us, 200 microfarads. Micro means 10 to the power of minus 6. Okay. So 200 times 10 to the power of negative 6 into 0.91 gives the charge on the 200 microfarad capacitor. Okay. So this is the answer for this one. Next question. Briefly explain why the data in the table provide evidence that the capacitors are connected in series. If you see this one, suppose if you take the 200 microfarad capacitance capacitor, the voltage is 0.91 and the other capacitor voltage, unknown capacitor voltage is 3.53. Okay. Suppose if we add these two, I will add and show you. 3.53 plus 0.91 is, what is the answer? 4. 9 plus 5 is equal to 15. So 4.44. Okay. And then the total potential difference is the battery PD is 4.5. That means the voltage of the battery is 4.5. This is, I write here, this is 4.5. Whether it may be this one or this one, this is 4.5. Am I right? See here, this is the 4.5. 1 second, I am writing here. The net is slow here. Okay. 1 second. This is 4.5. Okay. Now, the total, so here in this, suppose if they are in series, the voltage V must be V1 plus V is equal to V1 plus V2 plus V3. Am I right? V1 plus V2 plus V3. Here this is V1, this is V2, and this is V3. If they are in parallel, the voltage drop across all the capacitors will be the same. Okay. See here, if we add these two, we are getting this one for almost 4.5. No, 4.44 means 4.5. Am I right? That means they are connected in series because the voltage is different. Suppose if they are in parallel, the voltage will be the same. No. Here, if the parallel connection, the voltage across the 2 points will be the same because these are all parallel. Agree. But here, if they are in series, the voltage will be different, and then the total voltage, the supply voltage, the voltage of the together, that means V1 plus V2 plus V3 must be equal to the supply voltage. Okay. So therefore, we conclude that it is they are connected in series. Now, next question is, he is saying that the only device, measuring device available is a voltmeter. Then we have to explain why connecting the capacitors in parallel would not provide enough information to determine the capacitance of the unknown capacitor. We know Q is equal to CV or C, capacitance is equal to charge by voltage. Am I right? Here we have the only measuring device available is voltmeter. So using the voltmeter, we can measure the voltage. If they are connected in parallel, what happens? We can measure the voltage. So the same voltage is applicable for all the capacitors. And moreover, what happens here? We can't measure the charge using the voltmeter, and there is no other device to measure the charge. Am I right? So therefore, what happens? It is difficult to measure that is what he is asking. Briefly explain why connecting the capacitors in parallel would not provide enough information to determine the capacitance of the unknown capacitor. So voltage is the same because there is no other voltage across all the capacitors. The voltage is same. See here. Okay. But charge is different. Okay. And then we can't measure the charge. Without measuring the charge, we can't find out the capacitance. No. So that is the thing here. Okay. You see here, that is the same thing I wrote here. Okay. So this is the answer for this question. If you know the nature of the capacitors when they are connected in series and parallel, and then this is just based on RC circuits, resistance and a capacitor, how the behavior of resistors and capacitors connected in series and parallel. That's it. Thank you. Bye bye.